Hey there, everybody. So in the last videos, we were looking at graphing linear inequalities just one at a time. And now that we've got that under our belt, we're going to look at graphing systems of linear inequalities. So a system is two or more inequalities with the same solution region. Okay, so if you remember when we were dealing with systems of equations, where we would either solve by graphing, substitution, or elimination, we would get one ordered pair that satisfied all of the equations. And that would be the solution. That would be the intersection point of their lines. All right, but here, when I'm dealing with inequalities, the solution for a system of inequalities is the set of ordered pairs. So there's going to be more than just one. There's going to be infinitely many because they're going to satisfy all the inequalities. We're looking for that overlap in their regions. Remember how we shade when we're graphing linear inequalities. All right, so the region, what we're looking for is the region where the shading overlaps. So what's this going to look like? All right, how are we going to graph two of these and shade and all that stuff on one coordinate plane? Okay, so let's graph the system of inequalities. First off, we got to graph them. So we got to get them into slope-intercept form. So this first one, x minus 2y is greater than or equal to 4. We got to get this into slope-intercept form. So I'm going to subtract the x from both sides. So I'll get negative 2y is greater than or equal to negative x plus 4. Next up, we're going to divide everything by negative 2. And so we get y, and then we divided by a negative. So I need to flip-flop the inequality symbol. And my slope is going to be 1/2 x. And my y-intercept is going to be negative 2. So I get y is less than or equal to 1/2 x minus 2. So if I were to graph this, I'm going to start at negative 2. I'm going to go up 1 to the right 2, up 1 to the right 2, so on and so forth, just to get a couple points. And then I can connect the dots. It's less than or equal to, so since I have equality, it's going to be a solid boundary line. And then since it's less than, I shade below. So all I'm going to put right now are these little arrows telling me that I shade below. I don't want to actually start coloring it in, or else my diagram is going to start getting really messy because we got to still graph another line. All right, the other line that we need to graph is y plus 2x is greater than negative 3. This is the other inequality that we need to graph. So we got to get the y by itself, so I'm going to subtract 2x from both sides. So I'll get y is greater than negative 2x minus 3. Okay, so if I'm going to graph this one, I start at negative 3, and I'm going to go down 2 to the right one, down 2 to the right one, down 2 to the right one. Or I could go up 2 to the left one, up 2 to the left one. All right, so we got a couple points there. I'm going to connect them. It's going to be a dashed line because I do not have equality. And it's y is greater than negative 2x minus 3. So that's shading above the inequality, above the boundary line. All right, so now we need to identify what the solution region is. And the solution region is where they overlap. Well, notice down here, this goes up and this goes down, meaning that these are going to overlap. So this is going to be my solution region. I will label it with an R. And that's saying anything that falls in that region will satisfy the inequality. Okay, so let's look at some of these points and determine whether or not they're solutions. So we got, we got 4, negative 3. Yes, it's in the region, in the shaded region. What about 1, -5? 1, -5. No, even though it looks like it's in the region, it's on a dashed boundary line. Okay, it's on a dashed boundary line, so it doesn't work there. All right, and then last but not least, we got 6, 1. 6, 1 is this point right here. And that is a solution because it's on a solid boundary line. Okay, so since that one's on a solid boundary line, it does work because it's above the orange line and it's on the purple line. So that does work. That is a solution. It needs to satisfy all of the inequalities involved. Okay, so the dashed line, if it falls on a dashed line, it's not going to work. Dashed lines don't work because you don't have equality. All right, so part B, here we're going to use this as a U try now. All right, so you can either pause the video now or come back to it after I'm done. All right, but that's going to be a U try now that we go over in class. So try that out. Get them into slope-intercept form, graph both of them, see where the shading regions overlap. All right, then we move on to part C. So we get x is less than or equal to -3. So if I were to graph x is less than or equal to -3, that's going to be the vertical line. Vertical line through -3. And since it's less than or equal to, it's going to be a solid line through -3. And since it's less than, I shade to the left. And then we also have y is greater than 2. So this is going to be the horizontal line. The horizontal line through 2. And since I don't have equality, it needs to be a dashed line. It needs to be a dashed line, and since it's greater than, I'm going to shade above. So I'm looking for where the regions overlap. Hopefully you see that it's right here, because this is where I shade above the blue and to the right of the orange. So this is my solution region. Now the question is -3, 2 a solution? So -3, 2 is right here. It's the intersection point. Now, if we were dealing with equations, yeah, that would be the solution because it's the intersection point. But remember, it's got to satisfy both of the inequalities. It works for the orange one because it's a solid line, but it does not work for the blue because it's a dashed line. So is -3, 2 a solution? No, it doesn't satisfy all the inequalities. It's on a dashed line. Specifically, it's on the dashed line y is greater than 2. Because look, if I tested this point, -3 is the x, so I'm going to plug that in for x. -3 less than or equal to -3. That works because -3 is equal to -3, and I have equality there. Now if I plug the 2 in for y, 2 is greater than 2. That's not true. 2 is not greater than 2. 2 equals 2, but I don't have equality there. So the fact that it didn't work for one of them means it doesn't work for the entire system. Okay? All right, so moving on, now that we've graphed them, let's talk about how do we write them if I give you the graph. Okay, so if I wanted to do the solid line first, again, we got this kind of template that we need to fill out. Y, some inequality symbol, our slope times x, plus our y-intercept. All right, so it's probably easiest to start at the y-intercept. I'm going to do the solid line first. So that's 3. Then I need to find another point on the line and figure out what the slope is. I'm going to go up 1, to the right 1, 2, 3, to the right 3. So my slope is 1/3. And notice how we shade above our solid boundary line. Okay, so since we shade above, that means y is going to be greater than or equal to 1/3 x plus 3. So the first one, that's our first one. Now we got to do our second one. So we got y, sum inequality symbol, our slope times x plus our y-intercept. Okay, so again, starting at y-intercept probably, easiest place to start. We've got -2. Now I got to find another point on this. And the next one, let's do this intersection point here. All right, so we go up 1, 2, 3, 4. Up 4, to the left 1, 2, 3, to the left 3. So up 4 to the left 3, so my slope is going to be -4/3. And then with this dashed line, notice how we're shading above the dashed line. So that means y is going to be greater than -4/3 x minus 2. All right, it's a dashed line, so I don't have equality. All right, so to kind of just simplify this, my system is y is greater than or equal to 1/3 x plus 3, and y is greater than -4/3 x minus 2. And there is my system based off of this graph. Both are shading above, so both are versions of greater than. I got one solid line, so that's why we have a greater than or equal to. Okay, so just kind of fill out that template. Find all those parts. The inequality symbol, your slope, and your y-intercept. All right, so 2b, we'll treat this one also as a you try now. So reference the problem above it, and then work through b. All right, we'll go over those two you try nows, but that's systems of inequalities. All right, the only way to graph, because we're looking for a solution region, the only way to solve, since we're looking for that region, is to graph. Okay, so make sure you're practicing your graphing skills, both for graphing linear inequalities, if you're just doing one at a time, and if you're doing systems, where you got to do multiple on the same graph. If you have any questions, let me know, but knock out these you try nows. We'll go over them in class.